Section 6.2 Rational Exponents. To begin, what are rational exponents? In this section, we'll see how the exponent is effective when it is a fraction. If you're thinking square roots and radicals, then you're on the right track. That's exactly how we read rational exponents. Definition of rational exponent. For any non-negative real number a and any natural number index n, where n is not equal to 1, a number, for example a, so a raised to the 1/nth power means the nth root of a non-negative nth root a. So just for a quick reference, a quick example, if I have a to the 1/2 power, it means square root of a. If I have a to the 1/3 power, it means cube root of a. And if we continue, a to the 1/4 power, fourth root of a. Do we see a trend? Okay, example 1. Rewrite without rational exponents and simplify if possible. So here we have 27 raised to the 1/3 power. So this would be the cube root of 27. Can we evaluate this? Can we find the third root of 27? Yeah, we know that 3 to the 3rd power is 27. So our answer for this one would be 3. Next problem, ABC raised to the 1/5 power. So this would be the 5th root of ABC. And since they're all raised to the 1/5 power, they're all under the same radical. You can write parentheses or not, your call. All right, a new definition similar to the previous, a raised to the mn power. For any natural numbers m and n, and any non-negative number a raised to the nm power means the nth root of a raised to the m, or the nth root of a, all of which is raised to the m power. So if I can give you one quick tip, the denominator is your radical, and the top number is just your exponent. And that's how we read them. So let's take a look at example 2. Rewrite without rational exponents and simplify if possible. So if we take a look at 27 raised to 2/3 power, then I know my denominator, that 3, will be my root, and that 2 is just an exponent. So this would be, if we rewrite it, this would be the cube root of 27, all of which is raised to the 2nd power. So you can write it like this, or you can write it with that 2nd power on the outside. Your call. However you see it better fit for your problem. Now we know that the cube root of 27 is 3 because that's part of our first problem. So the cube root of 27, that gives us 3, and 3 squared is 9. So that would be our answer. Next problem. 4 raised to 3/2 power. Okay, let's begin by rewriting it. So that we have the square root of 4 raised to the 3rd power. Now we can go ahead and find the square root of 4. For square roots, we can write a 2 or not, your call. And that gives us 2, and 2 to the 3rd power, that gives us 8. So 8 would be our answer. So write a quick summary. Maybe you have a trick or a different way to remembering how you would write it from rational exponent to a radical. So in your summary, tell yourself, how do you go from this? How do you rewrite it? Or how do you think about it? What's your thought process? Definition of negative rational exponents. For any rational number m, n, and any positive real number a raised to the negative m over n power means 1 over m raised to the a raised to the m over n power. That is, a raised to the m divided by n and a raised to the negative m divided by n are reciprocals. So they're kind of like the flip. Now, the way I think about this, and the way one of my tutors mentioned it, is it's negative, meaning it's not happy. It's not happy living in the attic. So make it positive. So move it from the attic, move it to the basement so that it can be positive and be happy. So that's always how I think about it. If it's unhappy, if it's negative, either in the numerator or denominator, move it to the other side, either the attic or the basement, so that it's happy. And that's how I always remember it, and that story always stuck with me. So maybe I don't know if that sticks with you too. All right. Example 3. Rewrite the positive exponents and simplify if possible. So I'll be silly with the first one, and I'll carry that story. So I have 9 raised to the negative 1/2 power. So let's write it as over 1 since it's a whole number. Okay, it's negative. It's unhappy in the attic. So move it to the basement. So we're going to take that number and move it down. So now I have 9 to the 1/2 power. And now we don't have to keep it negative because now it's positive. Now it's happy. So on the top, I don't have anything. We just write a 1 placeholder. Okay, I know that a radical, well, let's back it up. I know an exponent that's written as a fraction is just a radical. So I have 1 over the square root of 9. You can write a little index of 2 if you like. All right, what's the square root of 9? That's just 3. So my answer is 1/3. I can't simplify that anymore. Okay, next one. Same thing. If it doesn't have a denominator and it's a whole number, you can just write it over 1. Now, it's unhappy in the attic, move it down so that I have 5xy raised to the positive 4 over 5 power. And it's right on the 1 on the top since it is not there anymore. Okay, I have 1. And let's rewrite it as radical. So I have the 5th root of 5xy, all of which is raised to the 4th power. You can write on the inside or on the outside, it's your call. And I can't really do anything with that 4th power. I can include it in, but I can't simplify any further. So this is my answer. Next one. Let's write it over 1. Let's make it happy. So that I have 64 to the positive 2/3 power. And the top I now have a 1. Okay, well, let's rewrite it as a radical. So I have 1 divided by the cube root of 64 squared. Okay, can I take the cube root of 64? Think about it. If you're ever somebody can think about it, is there a number that when I raise it to the 3rd power, I get 64? And yeah, there is, right? 4 is that special number. So this is equal to 4. So that I now have 1 over 4 squared. 4 squared is 16. So my answer is 1 over 16. Let's take a look at D. Now D is a bit more involved. So I see that I have 4x raised to negative 2/3 power times y to the 1/5 power. Okay, if it's helpful, you can write them all over 1. And then think, which one's unhappy? Which one is negative? while this one's negative. Let's just rewrite that one so that I have y to the 1/5 power in the numerator. In the denominator, I'm going to take that negative and make it positive. So I have 4x to negative 2/3. And actually, I already made a mistake because that exponent, we don't have parentheses telling us it applies to all of the 4x. So it actually only applies to the x. So that we have 4 on top. On the bottom, I just have that x to negative 2/3. And actually, I'm very happy I made that mistake because it gave us an opportunity to talk about this. Okay, so we were on the bottom, so it's now positive. No need to write that negative. So I have 4y to the 1/5 power divided by x to the 2/3 power. And that is all we can do. Let's take a look at E. Now, what I like about this one is it kind of brings up another one of our rules, one of our exponent rules. So this negative exponent applies to all of our fraction. Why? Because we have these parentheses, and these parentheses tells us that it applies to the entire number. So if I wish to make that negative, if I wish to make it positive, I have to flip my entire fraction so that I have 7s on top and 3r on the bottom, and all of that is raised to the now positive 5/2. Now, can I do anything more with that? No, I can't, right? So that's all we have for this problem. Okay, here we have our laws of exponents. Memorize them, have them on a post-it. They don't go away, and they're always there, kind of trying to trick you in all of your problems. So let's read through them. For any real number a and any rational exponent m and n, if I have a to the m times a to the n, if they have the same base number, then I only add the exponents. So I have a raised to the m plus n. If I'm dividing and I have the same base, a raised to the m divided by a raised to the n, then we subtract the exponents. And that's how we simplify. The third rule, a raised to the n, parentheses, raised to the n. If I have an exponent raised to a power using parentheses, we multiply. So we have m times n. Now, if I have two numbers, such as a and b, raised to the m power using parentheses, and the exponent applies to each number separately. And lastly, rule 5, a divided by b raised to the nth power, then that exponent applies to every number in the numerator and denominator. Okay, so let's go ahead and work these out. They're fairly quick. So here we see that they have the same base and they're being multiplied. So to simplify this, I just add my exponents. So I have 1/5 plus 3/5. Get 3 raised to the 1 plus 3, you get 4/5 power. And that's it. B. I see we have the same base and we're dividing. So we're going to go ahead and take our base and subtract our exponents. So I have top minus bottom, 1/4 minus 1/2. I need to rewrite it so I have the same denominator, 1/4 minus, I multiply by a 2/2 to get a denominator of 4. And I have 2/4 power. I have 17 raised to negative 1/4 power. And we want to make it positive, so I have 1/17 to the 1/4 power as a fraction. Next example, let's rewrite it as a rational exponent. So remember, your index is your denominator and your exponent is your numerator. So we're going to take our base of x to the third power, or just x, and we're going to write it as raised to the 3 divided by 6 power. And we simplify that fraction. 3 over 6 is the same as 1/2. So x to the 1/2 power. Now for this one, we have just the index of square root of 6. So I have 4, and I only have it once, so I write to the 1 over 6 power. And let's do the rest. So we have a squared and b to the 4th power, all of which are being raised to the 1/8 power. Now this exponent applies to each term. So that we have, let's multiply, a to the raised to the 2/8 power and b raised to the 4/8 power. Let's simplify our fractions. 2 over 8 is the same as 1/4, and 4 over 8 is the same as 1/2. Okay, let's rewrite it as rational exponents. So I have 5 to the 1/3 times 2 to the 1/2. Now we could add them, but in order for that to happen, we need to have that same base, and we don't have the same number as a base. So there's nothing else I can do with this problem. Try to trick you a little bit. Okay, let's take a look at example 6. Write a single radical expression for a to the 1/2 power times b to negative 1/2 power and c to the 5 over 6 power. Okay, if I want the same radical, I want the same index. So they all need to have the same denominator. So we look at 2 to 6 in my denominators. We all need to have a denominator of 6. So I need to take that a to the 1/2 power and multiply it by a 3 over 3 to make my denominator 6. B to negative 1/2 power multiplied by a 3 over 3 to make it a 6. And I have c to the 5th 6 power. So we have a to the 3/6 power, b to the negative 3/6 power, and c to the 5/6 power. Okay, let's make my b, let's move it to the bottom because it's negative, right? So I have b to the negative 3/6, a to the 3/6, and c to the 5/6. Now we want to write it as the same radical. So because we all have that denominator 6, I can write all of them under the 6 radical. On the inside, I have my number with their corresponding exponents. So I have a to the 3rd power, c to the 5th power, and b to the 3rd power. And that was supposed to be positive because we moved it down. That was very tricky. Problem 7. Write a single radical expression. Okay, so we have a 6, an 8, a 9, and a 4. So we really need to find the LCM so they can all be under the same radical. Okay, so let's go through the process of finding the LCM for all of those numbers. Well, before we begin, let's simplify. I see that we have x's and y's that we can work with first. So I have my x's and I have some y's that I can work with. And according to our rule of exponents, if I have the same base, I can subtract them, right? So I have x, and we subtract top minus bottom. So I have 5, 6 minus 4/9. And for my y's, I have 3/8 minus 1/4. So let's go ahead and subtract. So I have x to the, now we need a common denominator. So I think 18 will do the job. I multiply this one by 3/3, this one by 2/2. So that I have 15/18 minus 8/18. And y, now we want a common denominator, so we just multiply the second fraction by a 2. So that I have 3/8 minus 2/8. And 15 minus 8, that gives us 7. So I have x to the 7/18 times y. 3 minus 2, we get 1, 1/8. Okay, now if I want to write them in the same radical, I need to get the common denominator. Okay, let's find our lowest common denominator. Okay, I don't know what the lowest common denominator for 18 and 8 is. So I have to go through the process of finding my lowest common multiple. So I can get 18 from 2 times 9, 2 is prime. I can get 9 from 3 times 3, and 3's are prime. So for my 18, I have 2, 3, 3. For 8, I have 2 times 4, 2 is prime. Get 4 from 2 and 2, 2's are prime. So it's 2, 2, 2. So 2, 2, and 2 for 8. Let's multiply them all out. So I have 2 times 3 times 3 times 2 times 2. And that gives us 72. All right. I can get 72 from multiplying this by 4/4 and multiplying 8 by 9. So that I have x. 7 times 4 is 28. So I have 28/72 and y over 9/72. Okay, now that they all have that 72 as a base, I can take the 72 power, or the 72 root of x to the 28th power and y to the 9th power. And we have now written it under the same radical. This one was a lot of work. This one was super challenging. Okay, this was section 1.3. I'm sorry, 6.2. Thanks.